Where's the thing? Okay, I think we did it. Hey, everybody. Welcome to the wasmCloud community meeting for Wednesday, May 29th. We've got a super stacked agenda for you today. I'm pretty excited to hand it off to everybody who's going to be talking in the community meeting today. So, first, we're going to start off. I know that we pointed at the RFC and the PR for the Postgres provider last week. We actually have Victor here today to talk about it. And and then from there, we've got a couple of great discussion items, and from Liam's suggestion last week, a featured docs page of the week. So that should be pretty great. Um, I think without taking up any extra time there, I can go ahead and hand it over to Victor to talk about the Postgres provider and interface. Big part of the Postgres provider. Yeah, Victor, take it away.
Awesome. Thanks, Brooks. Let me share my screen. You can hear me okay, yeah? All
Yeah,
right.
sounds great.
Okay. So you should also be able to see my screen at this point. I'm going to drop a link to this PR in chat just to make sure everyone has it as soon as the chat comes up. But yeah, this is the PR to introduce a provider we've left out. We way back when we had two actual SQL interface providers. Back in the sort of Smithy days, we had one for Postgres and we had one for DynamoDB. Actually, if I remember correctly. So these are gone now. Since it's been a while. They were never great, or they were never, honestly, even kind of passable, just because they were done quickly, and we've always meant to improve on them. And now that we've got to 1.0 and the ecosystem has come so far in the last year, essentially, we've had time to go back and try to port the old stuff, but really just sort of newly imagine the interface and try and figure out a decent provider that works for accessing databases, right? Which is obviously one of the most important things that most people are going to want to do when they're using, when they're building applications, right? Anything that's useful, right, usually has a stateful component. I'm going to zoom in here so that everyone can kind of see. So there's already been quite a bit of discussion. So there's a issue as well as this PR, and there's been a bunch of discussion and discussion on the PR as well. But the most important bits of it are really the WIT interface. So this is the WebAssembly interface types interface for what we think in very specifically Postgres looks like. In the past, we've had other approaches, right? Like trying to define a shared interface between, like, let's say MySQL and Postgres and SQLite. And some apps want that, sure. But in general, it's probably not a great idea to sort of give up the benefits of a Postgres specific interface and sort of deal with the lowest common denominator all the time. So that's what we're kind of looking to avoid, and what we end up avoiding by writing a more tailored to Postgres one. Oh, can you not see my screen right now?
No, you're good.
We can
Okay,
see.
awesome.
I think that was just a hot
Okay,
mic.
perfect. Oh, no worries, no worries. Okay, so yeah, so that's what's kind of that's the point of this, is to really nail down a very Postgres specific interface, and also take advantage of some of the Postgres specific stuff that we want. So I'm going to work in the interface and kind of work backwards, right? I'm going to start from what we define the provider to be, and then sort of go back to the pieces that make it up. Before I do that, I do want to make sure that people know what I'm talking about when I talk about WebAssembly interface types. So if you look at this link, I'll also put in the chat. At this point, if you've been watching the live streams, you'll probably have seen this already and hopefully be pretty familiar. But basically, WIT is an IDL, but one that doesn't go over the network, right? So it sort of orchestrates or connects, let's say, via well-specified interface, pieces of compute or like, let's say, programs, but inside the process, right? And where the programs are sort of WebAssembly, right? They're WebAssembly binaries sort of put together and with what they do. So like, let's say their functionality and the involved types all written out very specifically. So if you want, you can, this document is actually very, very approachable, even though it's long. It is pretty long, but it's easy to read, easy to figure out. So this is the place you want to start if you want to understand the files I'm about to show you in depth. I'm going to explain them, but if you want to read more, this is where you would start. So we're defining, and at this point, again, this is all up for discussion. So if you've got comments, please jump in the PR, in the issue, or RFC, etc. We're defining this sort of Postgres SQLDB provider world. Now it's backward, it's written backwards here, but that's just for easy sort of lexicographic ordering. But we're defining it as something that exports this sort of connection interface, exports this managed query interface, exports a query interface, and exports, this is a prepared query interface. So like a prepared statement is the more sort of normal way to say it. Now, these are defined in other WIT files that happen to live in the same folder. So I'm looking right now at provider.wit right here. And in this same folder, there's some other files that define these particular individual interfaces. So if I jump over to connection, this might actually go out. It actually might go out, or at least might be disabled in the provider, since letting components create their own connections is useful, but might be more trouble than it's worth from a security perspective, especially like out of the gate. But we'll see. Again, happy to hear opinions on that. I know Taylor's weighed in and other people have weighed in. But in general, this kind of lays out what you'd expect from just about any SDK you'd use for Postgres or any other database, right? So we've got some sort of, and a record is kind of like, you can think of it as a struct or an object, without functionality, just the data, or a data class in Python, if you're familiar with those. And we've kind of got a host, we've got a port, we've got a username, password, database, whether TLS is required for our Postgres connection, kind of all the sort of basic things. We've got some more information, and this has to do with the provider, but this is basically trying to specify how we're connecting. So since our one provider handles multiple connections, so multiple components are going to connect to the same provider, be linked to the same provider, we have different connections that can be made available to each component. So you can deal with, basically there's one there's sort of like a default, or basically completely managed connection. There are some that are named. So let's say you want, the same component to actually be able to use two different connections, right? An easy way to do this without creating the connection inside the component is to use a sort of named profile that's already been set up. And then there's this completely manual option. And then here is what you might expect from most SDKs. You're going to see a create connection function, right? And it takes that thing we saw earlier, the connection options. This is the fully manual case. This is this connection options here. So the thing that tells you either you want the managed thing, you want the named thing with a given name, or you want the fully manual thing. So you've got that function that takes this and returns something, a connection token. So I won't get into it now, but WIT has support for sort of opaque types. So the ability to give back, let's say, a sort of placeholder that only the part of the program that sort of performed the action knows about, right? So here I use a token. Obviously, a component that gets this token back doesn't really know what to do with it. The token's actually just a string. It's like receiving like a session ID. You can think of it that way. So where do you use that token? Well, if we go to the query, let's see if I can actually, I can't minimize this. Excellent. But if we look at the query interface, we'll see that the query function, which is what you're going to use to perform an actual query takes a query connection token, right? And you can think of this as sort of the thing that matches your query to the connection you made earlier. And then you've got a query string and you've got a list of parameters to the query. Now, we do force all queries to be parameterized. I'm sure as anyone who's worked with databases for any period of time knows, not parameterizing your queries is basically the worst mistake you can make. Like it's basically a mistake that belongs in, I don't know, the 2000s essentially. But this basically means making sure that you pass your data for a query, the dynamic for data for a query that could possibly be user provided separately from the actual query itself. So your query is going to look like this. You're going to have you see that like sort of $1, and then that $1 is going to correspond to the first parameter in this third argument here. Now, the rest of the query interface is pretty simple. Easy to guess what the rest of it looks like. But what I will jump to is this PG value, because this was actually probably where the bulk of the work was. And this is defined in yet another WIT file, and these are interlinked, called types.wit. So I'm going to jump to the end here. But basically what we've had to go and do is translate all the values that Postgres can express, or at least the ones that we can express in WIT at the very least, into the representation as pieces of WIT. So as sort of in the WIT syntax and in the sort of WIT type ecosystem or type universe, however you like to think about it. So you see all the sort of familiar Postgres types. You've got big serials here, regular serials. You've got integers, integer arrays, numerics, etc. And so we just went down kind of through the list. Postgres is one of the great things about Postgres is that it has a really robust type system. So you can do things like store MAC addresses. You can store IP addresses. You can store CIDRs. And you can store things like actually geometries as well, which is actually really fascinating. And then you've got stuff like datetime, timestamps with time zones, timestamps without time zones, JSON. Yep, JSON-B and JSON. JSON is JSON-B is a special type that sort of stores JSON as binary data inside a Postgres database. It's not really important. It's massively beneficial on the database side, but we kind of take rather than making you give bytes, we kind of just give you can give a JSON string, which is a bit easier on sort of the front end of this. So we basically go through and we have a type that sort of defines all the possible Postgres types, or at least the ones that we can cover. And yeah, so this was basically the important part of defining this provider, sort of writing a thing to sort of shuffle a query to a connection pool is not really that difficult, but finding the edges and seeing what we can translate and what we can't into native Postgres types is what's really important. And so that was the sort of interesting work here. If I jump, so I'm gonna, rather than jump to the implementation of the provider, because we definitely don't need that, or we definitely don't need to go over that. What I'll show you is what it looks like when it's used. Before I do a demo real quick. So this is going to go into the examples, the Rust components examples. Oh, actually, before I go on, let me pause for questions. Are there any questions? Oh, okay, so I see Yordis had something in the chat. Okay, so some people use question mark instead of $integer. So question mark is also fine. So some people also use sort of dollar and then a name, right? Like, so you can have like named parameters. They end up being pretty similar. I personally prefer the dollar and then a sort of an integer, just because it's a little. I find that I make less mistakes with it, because you can generally kind of. Oh, and just to clear that up for Robin, it's not really a thing that Postgres supports. It's more the SDK, the driver that you're using is the thing that supports this, just to make sure you can't sort of do the like you can't do SQL injection by accident very easily. Here it is. This version won't have name parameters. Sorry, you should file that as an issue though. It's possible. It's possible. We just need someone to implement it. But yeah, I'm pretty partial to the dollar and integer, but anyway, yeah. So that's sort of a little point on that. But if anyone has any other questions, let me see. Oh, here's one. So Robin has a question as well. Aren't some of these implemented by Postgres extensions? Is there a distinction made between core types, or whatever they're called, and extension types in a way that's provided to extend these? There are 3 type systems at play here. So there's regular Rust, because the example happens to be written in Rust. There is wit, which is the sort of, you can think of that as the type system for the component model, or just WebAssembly in this case. And then there are types on the Postgres side. Now, normally you only have two type systems in play, right? Your driver is going to turn Rust types into Postgres types. That's normally what would happen, right? Essentially Postgres data to be sent over the wire to a real Postgres instance. In this case, we have sort of 3 steps, right? We start, because when you're writing your WebAssembly component, you're going to be dealing in Rust types that must turn into wit types, go across the wire to, and this is via WRPC for wasmCloud, to a provider that receives that wit type, turns it into a Rust type, and then passes it over to the database. Brooks?
Yeah, I wanted to let you get on to your example, Victor, and I guess my question clarification was really that a good chunk of the complexity, or at least like work in getting this interface together, seems like representing the Postgres type system in WIT so that you can work with that natively in WebAssembly. Is that a correct like assumption, kind of looking at this interface?
Yeah, that's true. I mean, there were a few questions and there are some things that aren't quite as easy to represent. So there are some types that didn't really convert cleanly. Oh, Taylor?
I didn't mean to interrupt you. I was just gonna tack on after.
Oh, okay. Yeah. So basically, yes, most types converted quite easily because they're basic things that exist elsewhere, and and most of them map quite cleanly. But there were decisions to be made on, like, for example, how to represent a timestamp, or Postgres actually has a native interval type, for example. That's actually one that didn't convert quite well because there's a bit of a lack of support. But yeah, that was basically the sort of more interesting bit.
Yeah. To clarify my question.
Oh yeah, go ahead.
I'm familiar with the way that like WIT and Rust work and sort of the type systems involved. The question more concerns when it comes to Postgres types. It's my understanding that some number of those types are core to Postgres itself, and some of which are defined by extensions. So there are Postgres extensions for geospatial data, for other things. And part of what I'm asking is, like, is there a distinction made between the types in this interface that are like vanilla Postgres versus the types that are only really exist and are only really available to you if you're using such and such extension? Or is the list you have here only those core vanilla types? That's what I wanted to try to get into.
Okay, I see. Yes, this is only core types. So these types are actually, even the geospatial types you saw there are actually native to Postgres. PostGIS and like other extensions add more, and they add more functionality, but those aren't covered in this interface. They can be, but that's sort of an extension. You would think of that as an extension of this interface and sort of in addition to it, rather than just the core stuff.
Interesting. That's surprising. I would have thought some of these would be only an extension.
Oh yeah, it's quite amazing. I mean, I don't know. I'm a big fan of Postgres, but it's just like the amount of things that they've sort of taken in, and some of them are bad, right? Like for example, the money type you should never use. Don't ever use the money type. It's a bad idea. Don't ever use a decimal to store money in a database, or use the money type that Postgres has. It's misleading. But yeah, it's quite amazing that they have stuff like just IP addresses and stuff like that, and you can actually do operations on them too, which is quite wild. And like there's some specialized index types that actually work with like things like an IP address, which is fantastic. But yeah, that's a great question, because Postgres is also well known for a wide array of extensions. So extending PG value in a flexible way to be able to like let someone bring in like a PostGIS and try and use some of the advanced types in there is actually quite interesting. I have to think about that.
Taylor?
Yeah, so just a quick question here. Is there something to be said maybe with all these types that it could be we start with a smaller subset and add the ones as needed, or do people want every single type defined? I'm just curious there with people in the community, because we could, especially uh with the whole upcoming thing with like synths and like like those kind of labels that let you add features in a non-breaking way. It might be easier to start with a simpler typeset if that's all people want. But I mean, I know you have the implementations there. I'm just kind of curious what people think.
I always
I'm definitely
generally use simpler types just because it's more flexible down the road. And that's just me.
Yeah, so this is actually something I end up mentioning in some of the comments and actually some of the error messages. Um, so the thing about Postgres is you can actually define your own casts from types to types in in terms of like in SQL itself. And for complex types that, for example, cast to and from a string, you can actually get away with, I wonder if I, let me see if I can just find the comment. I can't. It's probably minimized. But you can write a query such that you cast, let's say, a string into text, or just to make sure it's text, and then into a custom type. So as long as you have a type that can be coerced, let's say to or from like a number or a string or some other sort of Postgres core type, it is possible to support complex types that are not defined in PG value. But again, I'm definitely on the side of implementing core, making sure that's really tight, because that's what 90% of people are going to be using anyway. Like for example, if you're running an RDS right now, there's a bunch of stuff you can't use. But like right now, it is actually possible to use types that aren't representable because of the possibility of defining casts and using casts, etc.
Hey, Victor, I just wanted to see if we could move on to the demo and then maybe time box this one for maybe the next 5 minutes or so, just because we have other
Oh
agenda.
yeah. Oh yeah. Okay. I'll speed through the rest of this. Okay, so this is the component that we're about to run, but before we run it, let's just look at it, right? So we've got your usual WIT binding at the top. This creates bindings, and then we're going to basically use those bindings for the rest of the file. So that's sort of where this import comes from, is sort of generated by that first line. So we've got the sort of basic queries just here as strings. And you can see, like, I kind of just create a table if it doesn't exist already. It's kind of basic, whole bunch of just normal sort of Postgres stuff. We use a Postgres feature here, which is returning. So like, I think MySQL still doesn't have this, but you can insert and then get what you inserted back. So that's the insert query. Here in the example, we use the fully managed interface. So first, we call that first query, which creates a table if it didn't exist already. And normally this would not be the case, right? You should be running your migration separately. But let's just, for the purposes of demo, you can see how you would do that if you were, for some reason, doing it from inside a component. And then, so we perform the query. Now, here's where that PG value stuff comes into play. So when we run that sort of query interface, we've got the query, which is just a string, right? But we pass it also a list of the parameters. Now, they all need to be values that are PG values. So here we're clearly making a text value, and we're just putting in a simple text value. What you get back, of course, is a result of either a bunch of rows or an error. So what this component does is just very simply print that. In the interest of time, so we're already 2 minutes down, I'm going to run this real quick. Can you still see my screen? And do you see a terminal now?
Do you see a terminal?
Good.
But the text is maybe not AARP approved. There we go. Nice. That looks good.
Nice. We love our AARP members. Now, so I have wash running in the bottom here. I'm going to just restart it just so you can see what I'm doing here. So I'm going to run wash up, right? This starts wasmCloud, a single host, essentially a lattice with one host in it. And I'm going to run basically a just file that just does everything for me and then go through what happens. So at first, we're going to run Postgres, right? So we're just going to start a Postgres instance in the background. Here, we're going to run 16.2. We're going to build the Postgres provider. So this is just a Rust binary, right? This is a Rust binary that's been sort of augmented with WebRPC capability. Capability is a bad word to use there. WebRPC abilities, let's say. And then we're going to build from that binary, we're going to build the kind of file that we can load into wasmCloud, which is a provider archive. So the file that comes out of here is a provider.part.gz. The next thing we do is we configure the wasmCloud host and this is provider specific, right? This is that managed connection that I was talking about. So we've got a whole bunch of stuff, printing the password right here. Don't try this at home. Don't print your passwords in terminals on the internet. But this is local, so there's not too much of a need to worry. But we've put this config. It's called default Postgres, and that's what the provider is going to look for. Then we're going to deploy the WADA manifest, and this WADA manifest defines that component, that test component, and it defines the provider that we just built. Right? It loads this file that was built here. So after that's done, wash has started. So the wasmCloud host has started. That's down here. Right, so you can see some of the messages. And the application or the component along with the provider has started. And we can run the component with just because of how I've written it with wash call. So I ran it, like the script ran it, and this is what we got. So if you remember the code, we had the success, if it was successful, and whether a new row was inserted. Now, the data that came back, this is actually data all from Postgres, converted into WIT types, and with those types, converted into Rust types so you can see them and print them really easily. So you can see there's that. So there's multiple rows, and there's entries in each row for each column that is relevant, right? So there's an ID column. It's a sort of 8-bit integer in Postgres terms, and that is value 1. It's literally the first thing that's been inserted. And then you've got a description. It's a PG value text. You're going to see PG value a lot. One thing I added in the demo was a created at column, which is a timestamp with time zone. And so this is a bit interesting because here's that PG value timestamp with time zone. And this is one of the decisions that had to be made, right? Like how to represent a timestamp in WIT, which translates to Rust code eventually, right? So you can see that I've chosen to do what I think makes a lot of sense, which is have a timestamp, which is a date, the year, month, day, and a time. And in the case of Postgres, Postgres is only accurate to microseconds. So it actually doesn't make sense to hold anything other, like a sort of higher granularity. In fact, Postgres just won't give it to you. And also including a offset, sort of UTC offset. But yeah, so this is what it looks like to set up the component provider and then run a query against a database. The object you get back is pretty verbose, but that is sort of inherent to the features and capabilities of Postgres. All right, so I'm going to stop sharing there. Yeah, I don't know if we have time for any questions, but maybe let's keep going, and then, or just drop them in the chat, and I'll hit them.
Yeah, thank you so much, Victor, for the comprehensive overview on the interface, the provider, and running through the example. I think we had a bunch of really great feedback there and great questions. I definitely second that, Victor. Encourage folks to ask questions in the Zoom chat now. If you leave a comment on the live stream, I'll try to relay that as well, and we can pick it up in Slack and on the PR as well. I think we're going to try to, I think our plan is to land this provider, at least V1 of it, this week, like tomorrow. And then I'm sure that there's going to be some additional features to add. So that'll be really cool to see. So thank you again, Victor. Now, I did see in there that you were using configuration with a Postgres password. And we may know that configuration is actually not something that's stored in a secure way. One may be looking for a secrets management solution in wasmCloud for this type of configuration. Is there any way that we can store secrets and work with them in wasmCloud? I'm just going to go on mute for a second.
I was like, you just, I don't know, threw a whole curveball at someone, possibly me. Who'd have thought? Anyway, so thanks for the intro on that one. Yeah, so we've been thinking about secrets for a long time, actually. And specifically, when we talk about secrets, we're talking about application secrets and being able to access them from components and providers in wasmCloud. Up until recently, we haven't really had like a concrete idea of what to do about it. Config, like Brooks alluded to, is one way, right? As long as you really guarantee you lock down the underlying NATS bucket, but that's like a relatively new construct. It's never been something we recommended. But the only other kind of tool in our toolkit that we've had up till now is something like using like the Vault's implementation of a KV provider and linking that wherever you need to kind of dynamically query for a secret. We know that works because, like, frankly, we've built production applications on that architecture, but that's not really a long-term fix, and it never really was intended to be. So, oops, that's not the share screen button. Let me share my screen. We'll talk through the RFC on actually introducing a whole notion of actually having secrets be a first-class construct in wasmCloud. So it's a pretty long PR. I'm kind of going to try and do my best to walk through the highlights and say like the next 10 minutes. But the idea is we want to be able to have the host mediate connections between a provider or a component that happens to be requesting application secrets and some sort of a secrets backend. So think something like HashiCorp Vault or AWS Secrets Manager or GCP, or take your pick, right? Every cloud has something. Pretty much every organization has some sort of a solution for like a centralized, secrets system for being able to manage this stuff, right? And the idea here is that we can have the host similar to what we already do with the config service and the policy service. We can, when it starts up, we can point it at effectively a well-known subject that it can make requests to some sort of I was going to say component, but it probably isn't going to be a real component for a while. But some sort of program, right? Listening on NATS that can satisfy those requests, right? So this whole RFC basically proposes that as an idea. And the objectives I think that we're trying to really solve here, right, is to define this API, because we want to be able to have production wasmCloud clusters or sets of hosts be able to dispense secrets to running applications defined in WADM. We also need to make some changes to the host in order to replicate this, or to be able to have those secrets be passed around securely and be able to actually resolve. We're not actually passing around secrets, I should say. They're really referenced secrets. I'll show you in a second. But we also want to define a WIT interface for this so that hosts have a consistent interface that components and providers can consume, right, to handle those secret references and be very clear when you're actually using the concrete value of a secret. And then, of course, make some changes to the WADM manifest to be able to support this, right? So the idea at a high level is we're going to kind of piggyback on config in some ways to actually be able to store secrets references. And so, the big thing with the secret is, it's secret. You don't want that to leak. You don't want to just like write that out to your logs like Victor just demonstrated, right? Don't type your password to Postgres on the terminal. You're not going to be in for some good times. But there's a couple of interesting things that kind of we know, having run, production systems at various companies, that we need to be able to satisfy. So you more than likely will not have just one secrets system in play. You're probably going to have many. And not only may you have many different secrets systems, they might all be different iterations of the same system. So our naming structure needs to take that into account because, for example, you may be running several different vault clusters, right, at like a large company, and they may be all accessible from the same set of wasmCloud hosts, or they may not be, right? It's kind of up to you. So the proposal talks about effectively how do we basically make sure that that's all represented. So we're making calls to different backends that may be the same underlying code, but listening on different subjects, right? We can do that pretty easily with NATs. Other things that we talk about, right, is like how do we handle this all securely? The answer at a high level is basically we can take advantage of the fact that NATS has this feature called an X key, which is like an N key, except that it's not used for signing, it's used for encryption. So we can effectively encrypt all requests and responses for secrets on the wire dynamically per request, right? So you can't just sit there and like snoop them on the wire, right? If you have privileged NATS access to that particular subject. You can't, try and do like a replay because you're not going to be able, because even if you tried, like the server won't be able to decrypt it. Like you're not going to be able to deal with actually retrieving a secret, right? Because you won't have the keys. And so there's like a couple of specific subjects. This section that I have highlighted talks about like extensions, but I don't want to focus on that. Let me scroll down. So the API itself is like relatively straightforward. It's pretty lightweight. It's basically just like get secret and then like get X key, which I think is actually further. This is all payloads. Here we go. It's not what I wanted. Anyway, I want a bigger, this picture won't blow up, which is annoying, but effectively, like if you could read this diagram, which I'm going to narrate it to you because I don't want to switch screens at the moment. But effectively the way that this would work, right, is like a component, actually, no, I'm going to go down, we'll talk about WADM first, then that'll come back to the flow. So with WADM, obviously you need to like specify your secrets, right? And so a secret itself is defined, basically it has like a name and a source in the actual WADM manifest, right? And this makes sense if you've worked with, again, things like Vault, because you want to basically retrieve a value by like a key effectively, right? Which may be different per backend. Your secret's likely versioned, which you can provide the version or not. And if you don't, you'll just get back the latest secret, right? And then you have to say which backend you're targeting. So is it like your prod vault or your dev vault or your prod's AWS secrets manager in whatever account you're using? I don't know. That's up to whatever you're running. But within a WADM manifest, right, you will specify that either in a couple of different contexts. And again, this is like identical to the way config works right now. So you can specify it kind of at the top level. I refer to it as like entity scoped. That's like at a component or provider kind of top level in your manifest. So in this case, right, with what I have highlighted, this particular HTTP component, is trying to reference two different secrets from two different secrets backends, right? The first one is it's called some API token. It wants to pull that from Vault at a key rooted at secrets test value, and it wants version 1 of that. And then there's another secret that it's trying to reference from Amazon Secrets Manager, right? Its value is very cleverly called secrets name. And its version is just some UUID because that's just how that backend works. In addition, you'll also be able to define what I kind of started to refer to as like link scope secrets. And it's the same thing with config, right? It makes that accessible to whatever happens to be consuming or targeting the link. So on a source, the potentially only your component within that context of the source will be able to reference that secret, or your target, for example, within the context of that provider instantiating link will be able to get it. Now you can have a bunch of different, like I'm playing with the idea of having a couple different, or like an alternative reference, like as a URN, instead of having kind of like this 3-part reference in YAML. If you have a preference, let me know and comment on the RFC. Keep going back and forth as to whether or not that's a good idea or if it's just going to be confusing for people. And you can take a look at the kind of complete manifest. There are a couple, there is an inherent like change to WADM, or like the manifest spec in particular, kind of rolling up, because where we have target config and source config, that's confusing if we're also trying to refer to secrets within the same block. So this is also kind of proposing we rename those to target and config with underlying secrets and config like sub blocks in them. We can do that in a backwards compatible way, like if we kind of handle that all within WADM as we parse manifests, but that's kind of just details. The other cool part, or I think it's cool anyway, and Bailey kind of pointed me at this initially, is so we also have the WIT definition of what it would be like to actually work with this in scope of a component or provider, right? And what's cool about WIT, and Victor's kind of chatting about it a little bit before, is that we have, it's an IDL, so we have different ways to represent data. But what's cool about WIT in particular versus, say, like protobufs or Thrift or other IDLs is that it inherently builds in the notion of like a reference that's a resource. So you can be really rigid, or rather, we can be really rigid about how we actually access these secrets in scope of a component or a provider. So the WIT API as proposed exposes one function, get, which makes sense because you want to get a secret, as a key. Now we can get away with this just being a key within this call, because in WADM we define what that actually means. That a secret has a name, which actually is that 3-tuple of an optional version, the actual secret key, and what backend you're targeting. So we can kind of decompose that into one thing. But because we have like the host is mediating this connection for you, this resource is the handle we would actually be passing around and passing back to the caller, which I'll show you in a second. But that resource has a method called reveal, which will actually get you back the secret value. Why that's cool is because you can audit and code every single place where your secret is revealed to make sure that that is not being exposed in ways that you don't want, or logged, or whatever, right? It's really nice because you can basically statically analyze that if you wanted to. And so what that would look like in Rust from like a components perspective, right, is you basically would call just like this get on my secret, and if you needed to, or when you actually need to get the secret value itself, you call reveal. The one thing about secrets too, or another thing about it, is we explicitly call out the difference between sometimes they're strings and sometimes they can also just be like arbitrary bytes. And so a variant is like a union type. It's one or the other, not both. So you can know upfront, right, which type it is. And we do a little bit of inferring to kind of guess. A lot of that's kind of going to be up to the underlying backend config to define. So anyway, that was a bit of a whirlwind overview of the whole thing. So there's a couple other alternatives we kind of considered and mostly rejected them. I'm hoping one day these backend components can actually, or rather these backend services can be fully implemented in WASM. We're not going to do that in a first pass. I think that's more of like a wait for threads to become a little bit better supported, like wasmP3, and then we can do it. So yeah, that's basically the proposal. Looks like there's a bunch of chatter.
Only people saying that this looks awesome, I think.
Okay, yeah, I was trying to see if there are any questions, and I see no questions. Does anyone have any
Yeah.
questions?
Yeah, so I saw one of the design considerations was, and I think you explained it, but it just wasn't as, maybe I wasn't listening at the time. One of the considerations is you don't want every single execution of a WASM to component to require a
Yeah.
connection to to Vault. Could you just kind of go into how you solve that problem for this implementation?
Yeah,
I know that it's kind of
so a lot.
but yeah, you could. Sorry.
No, a lot of it's a great question because it definitely took a little bit of discussion between like a few of us. So the host needs to basically cache all that, and so the host, because it's sitting in between your component and your secrets backend, right? When it instantiates a component for the first time, like it basically, you're telling the host to actually start the component. That's when it actually resolves all of your secrets right then and there, right? And so what it does, it'll cache all that in memory, right? Probably using the secrets crate to make sure that we don't in turn leak that value anywhere. And then so anytime your component starts, right, it's provided that handle, right, as part of, when it actually instantiates the actual underlying component or module, right? Same as a provider, right? It's all kind of like in that linear memory connection. Now, the obvious question there is like, well, what happens if I change my secret? That's why I use versions, because then when you need to like rotate an API key, you would roll that out via WADM, which would invalidate effectively the cache that the host has, and it'll refetch it at that time.
Is it
The
more like
reason
a
why
cache miss, or is it actually invalidating? Oh, sorry. I
it's
was
more of a
supposed to not.
cache missed probably.
Okay.
We haven't implemented it yet, so like we could straight up just like flush the whole thing for the component at that point. I could see arguments either way. I imagine we may just flush it, but we'll see. The cost of retrieving the secret is not crazy. It's just I think as you were getting at, right? You don't want to do that every time because that will just slow down all of your component invocations. And in a busy system, you're going to just be sitting there, right, thrashing the whole time and waiting like, upwards of a couple seconds at worst, right, to pull all that down from Vault every time. You don't want to do that. It's the other reason why we're trying to move away from proposing that like you just, link out to the Vault KV provider anytime you need a secret, because again, that can be slow.
Yeah. Oh, I don't want to take up more time, but definitely talk about this for a
Yeah,
while.
we can chat after if you got more questions. I see hands.
Yeah, I just raised my hand since we're running a little tight on time.
I figured.
Make sure that Taylor had enough time to go through the incubation process changes and some of the documentation that we put out. I know that it's not ideal, but please, 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 if you have questions or feedback, leave those on the secrets RFC, which is linked in the community meeting agenda. And if you have any questions, please feel free to reach out on Slack as well. We can always go back and forth there. Bailey, I know your hand's up, so I'm not trying to clobber over that.
I'll go quick. Is that okay?
Sure.
I just wanted to say that really appreciated Dan's design here. I think it's really powerful. One thing I just wanted to have said is that this is a new paradigm that basically literally nobody else can do except with this technology. And I'm just so incredibly excited about it. Being able to use techniques like opaque resource handles inside the interface definition and being able to analyze which components at the get side were able to unveil a secret statically, declaratively. So cool. Yeah, you can implement a lot of stuff with OpenAPI and go really, really deep and all the different conventions that you have to create with REST. Whereas this is declarative, and you know that the component and system have to function the way that this interface contract is designed. I'm so geeked about it. I can't wait for blog posts and more things. Thank you.
All right, Taylor, I think you've got spiffy couple of minutes to talk about incubation things. So
Yeah, rapid fire.
some of
So
it next week if you want.
no, this will be real quick. So I put this in the wasmCloud Slack, but in case you didn't see it, I'm grabbing the lazy link right now. Just a second. Um, we did an update just on the wasmCloud incubation process. The long story short is the CNCF, especially the TOC, was working on streamlining and updating the process to make it a lot clearer, which they did. We created a blog post that kind of explained our feedback on it, both positive and constructive feedback for it. But basically, we've kicked that off. We have all the things in line, so we should be able to start getting to this fairly quickly now. So we'll see how the incubation process goes. I can't give you an exact timeline because I don't set it. But they do have to do a couple different things about talking to some of the adopters and talking all that. So we might be reaching out to some of you in the community who've talked publicly about it. So the TOC might be able to get in contact with you. So that's what's really like the only thing that's gonna be different right there. But yeah, we're just working towards moving that on to incubating. So that is the blog post. Anything else there? Any questions? Okay, next one, which is real quick. Brooks, I can just let you share your screen on this. We have WDAM 0.12 is out. It is not yet integrated into Wash yet. And it'll be in the next version of Wash by default. There is a major breaking change to this in terms of the API. Unless you're using the API directly, though, that shouldn't really affect you. We'll account for it in the tools, especially in Wash. But basically, we made deleting a lot easier. And the other big UI, the big improvement here that I want to call out is for those of you who've been doing this for a while, versioning sounds great, but it didn't really work out in practice. So what we did was we removed the requirement to specify a version. And so if you still specify a version, it'll work. But if you don't specify a version on your manifest, it will automatically generate one, which means you can just keep putting the manifest. And you won't have any problems with saying that version currently exists. So this should really help out with the local dev flow. So the other big thing is we also released crates. So we broke out the WDAM types into their own crates so they can be used anywhere, including in things like WebAssembly and whatnot without any extra dependencies. Outside of like 30 for deserialization things. So that's there, as well as a new client crate. We now had 3 different projects trying to do this between the operator, Wash, and then Luke in the community has also been working on a WDAM provider and interface. So like that was now 3 different things. So I was like, okay, I need to finally just whip out that client. So we put together client, and you should be able to put that together as well. So that's all my quick news for WDAM.
Just to kind of continue off of that, Taylor. I wanted to know because I thought about this a good bit around this breaking change that if you're using Wash and you have any scripts or any flows that you're used to working with, this shouldn't actually break you as you move forward with the new version because not specifying a version before wasn't a valid command. So you shouldn't accidentally like trip and shoot yourself with this API change, which is really nice. Speaking, personally as somebody who mostly uses the CLI to interact with Wattum, so that's good. Now, if you were using the API directly, that might be something that you need to worry about. And if you are using the API directly, good to note, we've actually updated the Wattum API docs, which is our featured documentation page of the week. Thank you, Taylor, for putting this together. So if you're using the API directly, maybe in a Kubernetes operator or something, this is a great resource for what the API does directly, all of the cruddy type endpoints for getting manifests, deploying models, managing existing deployments. This is a really comprehensive guide around what the Wattum API is like, and this is all over NATS. So everything is essentially in line here, but this is a great resource for taking a look at what is actually going on under the hood with the Wattum API. That almost got me, Taylor. I know that we are at the end of time for the community call today. But I will just pause really quick. Is there anything else that folks wanted to say for Taylor on the incubating process or on Wadham? All right, everyone. Well, dang, what a great community meeting today. We got Postgres, we got secrets provider proposal or secrets proposal in wasmCloud. We got new and improved incubation application with the new process in the CNCF. Big moves this week. So thank you everybody for being here, for asking questions, giving feedback. I really appreciate it. And I'm looking forward to next week where we can go back and do the same thing. Well, let's keep the conversation going in Slack if folks have anything else that they wanted to talk about. I'll go ahead and end the stream here and